Hello, everybody. Welcome to this coffee break with Eddyfi Technologies. My name is Paul Hillman. Thanks for joining me. I'm based in the UK. I come from the recent merger of ZTech with Eddyfi, and very happy to be part of the Eddyfi group now. And today I'm going to be talking about the TOPAZ range of instruments with the UT phased array instruments coming from the ZTech business. So I've got a PowerPoint to show you, and we're going to run through that, and I'll hopefully do a little bit of live demonstration as well, and we'll have time for questions at the end, and feel free to write those questions in as we go along. So here we are, the TOPAZ family of instruments. So what are they? We have 3 TOPAZ instruments in the range, and TOPAZ are the portable phased array instruments available from ZTech. So we have the 16, which is a 1664 or 16128 instrument. We have a TOPAZ 32, which is a 32-128 PR instrument, and we have a TOPAZ 64 instrument, which is 64 or up to 164, 64-128, doing TFM, FMC, plane wave imaging, all the bells and whistles. The key thing about the TOPAZ family, we have them all running the same software, which is UltraVision Touch. It's the same engine as our main UltraVision platform. It's a very powerful software. And I'm going to talk a little bit about the capability of the Touch version and the Classic version we have offline. It's called Classic, but a lot of its features are pretty futuristic, actually. So, all right, so I'm going to go through the instruments a little bit just to explain some of the features. The top end of the TOPAZ line is the TOPAZ 64. Again, it's a 64-128 PR instrument. It's a very high quality signal instrument and high data throughput. So it does phased array, it does TOFT, and it does conventional UT and FMC, TFM, and plane wave imaging. We have a connector there for 128 channel phased array. It can either be a ZPAC, which is a ZTech connector style, or IPEX, which is a sort of industry standard universal style phased array connector. We have 4 limiters for TOF channels there. It has a large display. All the screens on the TOPAZ instruments are pretty bright and easy to use. They are multi-touch displays, much like an iPad type display. So if you're used to using one of those, navigating is pretty straightforward. We can do multi-group with it. In fact, with all the TOPAZ, we have effectively an unlimited number of groups, or what we call channels on UltraVision. We're only limited by the number of focal laws, and of course the space on the screen if we want to display everything. And as I mentioned, we do FMC and TFM, so either live TFM or saving raw FMC data for offline processing, and phased array, of course, and TOFT, and plane wave imaging, which is a very fast way of doing TFM imaging with less firings and high throughput in terms of speed. The instrument has a bipolar pulse there as well. So when we activate this, we basically use a half wave negative. This is the pulse we apply to the probe, followed by a half wave positive voltage pulse, and it gives us about 40% more energy than when we just use a unipolar pulse. All of our instruments as well have a 2-stage analog amplifier, which means basically for applications where we're requiring a lot of power, a lot of gain, we get real benefits on this platform. So with doing live TFM with this instrument, we can do up to 1 megapixel frame size per channel, so 1024 by 1024 pixels. We can do multiple live TFM reconstructions at a time as well. So for each channel we're doing TFM, we can do up to 4 reconstructions. By reconstructions, I mean wave path reconstructions. So people may have heard the terms TT or 4T or 3T or LLT. These are different reconstructions, and we can cover those in a different discussion. But at the same time, live, we can do multiples of them. So up to 8 when we consider doing 2 TFM channels at the same time. And one nice thing about the TOPAZ is when we're doing TFM, if that's what you want to do, we can do TFM on multiple probes. So 1 probe either side of a weld, for example, at the same time as doing phased array on those probes, and at the same time as doing TOF. So in one acquisition, 1 pass of the scanner, we can save all of that data from all of the channels into 1 data file for easy acquisition and analysis and making sure all of our data groups are lined up. And of course, that gives great efficiencies. We have a very fast TFM acquisition rate for TFM and plane wave imaging. That's industry leading for this type of equipment. And we can do raw FMC data saving. So what I mean by that is normally when we do TFM live on an instrument, we capture the FMC data, we process that into a TFM image, and then the FMC data is discarded. But we can also save that raw FMC data for offline data processing, where we might want to reconstruct in different modes using different algorithms and maybe different resolutions or different wave modes offline in UltraVision Classic. So we can save the raw FMC data either for a single probe position or for an encoded scan. So we can scan along a weld, for example, and save the FMC for all of that. We get big data files, but it gives us a lot of capability offline for optimizing the imaging. The TOPAZ 32 is the instrument in the middle. This is 32128 PR, and it's really the workhorse of weld inspection. It's got similar characteristics to I mentioned in terms of the electronics to the TOPAZ 64, and we have two UT channels still, so 4 LEMO connectors for separate TOFT. If people want to do more TOFT, we can use a splitter from the phased array connector, of course, to add more TOFT channels. It says multi-probe capability there. It gives an example of 2 phased array and 2 TOF. It can be more, depends on the element count of each one. But we have a 32128 there, so 128 channels available, plus 2 additional TOF channels. As well, unlimited groups and 2D matrix array support. So for those applications for austenitic steels, stainless steels, we can use 2D matrix array, and it's all supported on the onboard calculator to configure those 2D matrix probes, so no need for an offline software to configure those. We also have a unique feature on this instrument called time reversal. It's typically used in the aerospace industry, but in short, it's a method for measuring a surface profile of a component that is changing along a scan length, and live we will adjust the focal laws so that as we scan down and the profile changes, all beams will enter at 90 degrees to the surface, typically used for composite radii or a complex composite part surface. And the TOPAZ 16 is the entry level, if you like, to the TOPAZ family, the 16, 64, or 16, 128 it's available in. It's small, but it has a large display for its size. Again, multi-touch, bright display. And we have a conventional channel there for an additional TOFT. And like the others, we have unlimited groups. So it's a great instrument for corrosion mapping and for weld inspection using multi-group. As a rule of thumb, we say for 16 elements, typically up to 50 millimeters thick weld in carbon steel or 2-inch thick weld, this is a perfect instrument for that, and it will handle multiple probes and multiple channels. So a little bit about the UltraVision software platform. As I said, on the instrument we run UltraVision Touch, so it's if you like, a stripped-down version of the main UltraVision platform, but with the user-friendly interface. So we have buttons we can use with our fingers, we can pinch and zoom and move things around. There's also a version of UltraVision Touch available on the PC. So there's a viewer which is free. Anybody can use that and open a data file, have a look at it with UltraVision Touch. There's the ability to remotely control your TOPAZ from UltraVision Touch on the PC as well. If you connect your TOPAZ via an Ethernet cable, the TOPAZ acts as the license for the PC, and you can drive it remotely. And then we have a standalone version of UltraVision Touch, so it's exactly the same as on the instrument. And there's quite a lot of capability in UltraVision Touch. So for most applications, UltraVision Touch is everything you want. So it has the onboard calculator for setup, scan plan design, of course, acquisition, and for data analysis, we'll cover a bit more of this in a minute, but we have the tools available for doing some processing, measurements, and reporting. So a little bit of a look around the UltraVision Touch interface. For those not familiar, it's pretty easy to navigate if you're used to some historical instruments as well. We have a file menu on the left. We have a large button in the bottom left corner, and the logic is we go top to bottom, left to right during our setup. We have quite a bit of freedom as well around that to configure inspections exactly as you like, but there's a process to follow for setup. There's some tabs on the bottom there for contextual menus as well. There's a gain control button top left, so we press it, we can toggle the gain up and down. We can also hit that calculator and punch in a value for gain. You have your battery status icons. All of the instruments have 2 batteries, and they're hot swappable, so you can use them on the fly, and it tells you how long you've got left there. We've got your scan and index position locator information, so where your scanner is at the current time, and then we have the calibration indication icons. So just running through them there, we have element check, wedge check, velocity, wedge delay, sensitivity, TCG, and reference gain, as you would expect. If the one in the main screen is green, it means all channels are calibrated. If it's yellow, it means some are calibrated, some are not, and gray means none are calibrated. And you quickly press that, and it gives you a list of all your channels for your detailed information on what channels are calibrated. Top right, we have the field display for measurements. So there's some options there depending on your application, some predefined ones to give you the readings you need. And you can also define your custom ones for those advanced users who want to display some particular readings. You can hit the Define Custom button. And there's a button at the top right to toggle to use a full screen during acquisition. Current version of the software is listed there, and you can download the latest version from the website, and the shutdown button is in the bottom right. A nice thing about UltraVision Touch is if you're stuck, if you're not sure about what the value means, you can do a long press with your button with your finger on the screen, or right click if it's a mouse, and you can open there a description of that feature. So it really helps the user to understand while he's out in the field. So for scan planning on board the instrument in UltraVision Touch, we have the specimen creation tool. So you can create your specimen on board for pipe and plate, and you have an automatic weld overlay generated from that. You can also import DXF files, so 2D CAD of your component to use as the specimen or weld profile. There's an onboard focal law calculator, of course, with visual feedback directly. You can do ray tracing to show your coverage. One really nice thing is we can do beam simulation on board the instrument. So we can simulate the acoustic field of each beam that you're creating, or one of the beams or more of the beams, depending on what you choose, to see what is the beam profile in the area of interest. How big is your beam spot size, and is it coherent? What is the focal zone length, etc. So it's a great tool for validating your setup on board the instrument. There's also calibration tools there, or setup tools for TOFT, of course. Just to give you some screenshots of the scan planning views. So the top middle display there is the ray tracing. So the blue lines representing each beam we're creating to show the coverage of the weld. The red area is the area that we're going to save. So we can define in this tool the area we're going to store, and also that defines our UT start and stop on our UT settings. A nice thing with this tool is we can set a distance range. So if we're doing weld inspection, you can see there we have vertical selection of around the weld, so that we're not saving lots of high angle information and having a big data file and our weld squished up onto one side of the display. It makes up for a more efficient inspection. On the left, we can see the coverage with all the beams simulated, so we can see the acoustic field of all the beams overlaid together. On the right, there's a display of each beam sequenced through to show the response from each angle we're creating. And the bottom one is one used for TFM on the TOPAZ 64, so acoustic field simulation of the particular TFM mode to see where we're going to be most sensitive with that TFM mode. For setup, we have some predefined layouts on the instrument. You can pick and choose for some standard applications. Something nice is you can create the layout as you please. So you can chop up that display, and you can put different information into the instrument display. So choose what view you want from which channel and where to display it, and you can have as many as you like. Of course, there's a limited amount of screen space, but you can add things like small couplet channels on the corners and things like that. So something really nice we do live on the TOPAZ is a volume corrected view by default. So when we look at a C-scan, and you can see these in the bottom left and bottom right, these are two C-scans. These are a true top-down view of the weld. So a lot of people using phased array instruments are used to seeing a C-scan, which is scan direction versus beam angle. And in that case, it's difficult to see when you're scanning exactly where an indication might be without going back and looking where it might be within your weld without going back and looking a sector scan. With a true top-down view, you get a good appreciation immediately of which position your defect is within the weld. So we do that live during acquisition. Of course, we have those displayed afterwards as well. We have a proposed setup button, which I hope to show you in a minute, which helps speed up the setup and acquisition. And there's, of course, calibration tools for your element check, wedge check. That is to check your element sensitivity. Your wedge angle is correct, your wedge height is correct, the probe is the right way around on the wedge. So we have some automated tools for this on board. During inspection, we have online merge views. That's what I just mentioned about having true top-down view of the weld, for example. A nice thing we can do is have a camera kit available, which will sit on your scanner. You can have it pointing at your probes, and during your inspection, you can see the live position of your probes. But in addition to that, we're also storing the views of that camera inside the UltraVision data file. So for each probe position that you collect UT data, we're going to save a view from the camera. And that means later on when you go for analysis, or you come back to review that file, as you scroll through the data file, you can see the position of the cameras when you took that inspection, which helps you verify were the probes misaligned, were they in the correct offset, was there a problem with coupling, etc. Of course, we have motor control support. So we have a couple of motor controllers from Zetec. We call them ZMC2 and ZMC4, which can drive motorized scanners. And we also can be compatible with third-party motor controllers to drive directly from UltraVision motorized scanners. And for analysis on board the instrument, we have some advanced tools like volumetric merge. If you're not familiar with that, that is where we might take data from two channels or two probes or all channels and merge it together into one data set so that we have one complete view of the weld, and we can do that directly on board the instrument. We have automatic amplitude drop sizing. So if you were to box an indication between your cursors, you can have it automatically read the minus 60 points and measure in 3-axis the floor size. We have some top processing tools, so lateral wave straightening, lateral wave removal, of course, a data file merger. So if we were to take multiple scans, maybe it's along a scan length, we might take 2 scans for a very long part. We can merge them together afterwards with a data file merger, or it might be that you've taken a scan of one side of the weld and then the other side of the weld in 2 separate scans for whatever reason, and then you can merge them together into one data file on board the instrument. For corrosion mapping, there's a similar tool called C-scan stitching where you can merge and move around the C-scans to correctly line up things, and there's some onboard tools there for corrosion mapping, for statistical analysis, and adding indications to your report and making a report. This is what a report could look like. So we can put particular logos, of course, in the top corner. We display the 3D view of the component, and then for each indication, you get a screenshot and a nice red box showing you where each indication is. So straight off the instrument, you can export that as a PDF or a text file to edit offline. You can do screen captures and offline create custom reports. We're also compatible, of course, directly with the UltraVision Classic package, which is on board the PC, but offers a lot of more advanced tools for design of inspection, either for simple components or for true 3D components, where we can import CAD models of your component to design the inspection, and also load the data back into that environment for proper analysis in the 3D environment afterwards. So it's used for inspection technique development to check coverage and capability. We can do things like 3D beam simulation as well in this software, and for data analysis and reporting. Some advanced tools we have on board this software, as I mentioned, the 3D data plotting and visualization. We can reprocess FMC data offline using multiple TFM algorithms. There's a new frequency filter tool for advanced applications where we can analyze a data file, have a look at the frequency response of a particular indication, and then filter other frequencies to help optimize the data. We have rule-based automated analysis, which is has been developed over quite a number of years, and we've had it there for a while. But it's a way of setting some rules about your defect criteria. So you set a detection threshold in percent, amplitude, or in SNR. You set some minimum size requirements of your indication and any grouping rules you have, and then the software will automatically box those indications, measure the 6 dB drop, for example, and put them in your indication table for the analyst to assess. And there's a data compare tool as well. So you can take a data file today of one component, take a data file next year, and just look at the differences in those data files for any indication growth, automatically compensating for sensitivity changes and slight position variations in those data files. Okay, I'm just going to jump onto the TOPAZ to show you a quick live demonstration. I've got my TOPAZ here live sitting in front of me, and I'm just going to run through a quick setup for you to show you the rough workflow of how we would do that. So the first thing would be to do is define my specimen, and I'm just going to do a simple plate weld here. So I'm going to set my thickness of my plate to 19.4 millimeters. You see we have a 3D view of this component. I'm going to choose a V-weld, and set my cap height a bit smaller. So this is my weld. I can change my view to an end and just have a look at the weld profile, and it's good for what I want. So I'm going to say accept. And I want to show you the proposed setup button here. So this button on the right, proposed setup, it's going to look at the weld profile that I've created, and it's going to create a setup automatically for me based on full volume coverage of that weld. So it gives me a few options in terms of what probes I have, and I can select them from the list. And it tells me the approximate setup it's going to do for me and asks me to verify that I'm allowed to do it. So it's going to create that setup for me. The layout is created automatically, the channels are created automatically, and it tells me here in this box where I should position my probes on my scanner. So in terms of index axis for my phased array probes and my TOF probes. So here it's created a skew 90 group for me for one side phased array. It's created a skew 270 for me for the other side, and it's created a TOF group for me. So I can have a look at these. If I go into my channel menu and into my calculator, I can see a view of one of the channels there it's created on the skew 90 side. I can view all channels by toggling this button and maybe have a look at the top view so I can see the probe separation in relation to my scanner for that particular setup. I can also do beam simulation. So using this button here, I can simulate the acoustic field of my beams to check my beam profile is good. By default, it's going to do 3 beams, my first, my middle, and my last. I'm going to reflect it off the back wall to check that I'm getting a good sensitivity in the area of interest. I can do more laws by changing this number here, and it's going to recalculate that for me. I just want to open a data file as well and show you a little bit of captured data with some camera views in. So I went to open data on my instrument. I'm opening a data file, and this has got, again, 2 phased array channels, C-scans on the left and right. These are true top-down C-scans. So you can see the weld overlay also displayed. So the 2 parallel lines in the middle is the root of that weld, and then you see the weld toes further out and the has zone, depending on if that's configured. So using my data cursor here, I can scroll through, and you can see in the camera views, I get a view of exactly where my probes were during that acquisition. So it's a great tool to verify after the inspection. Okay, and the next thing I want to show you is just switching over to UltraVision Classic to show you the environment we have there for doing some more advanced things. I won't show everything, but this data file I have in UltraVision Classic is captured on a weld, again a 19.4 millimeter thick. I have 4 TFM channels that have been run simultaneously here, so 2 on each side of the weld. We have a TT mode, so a direct path mode, and a 4T mode for each side. So you can see them displayed here. This one is the SKU 90 TT, this is SKU 270 TT, and this same on the other side. And these are my B and C scans. I also have a TOFT channel in the middle here, which I can zoom in on a little bit for that same welded data. And what I've done with this data is I can analyze it here, and I can have it measure my indications. And I can also have a look if I merge that data together in a volumetric merge. So you can see here my TOFT data, which is of course the grayscale data here with the A scan from the TOFT. I have my B scan. So this is depth in the plate, so top of the plate, bottom of the weld, and I'm looking side on, and I can see my indications, one here, one here, one here, and one here. And I'm doing a C scan here as well, and this is my end view. So at the moment, this is showing all of the data along the weld displayed in one view, and there's a 3D view at the top here showing all that data. What I can do is link some views together. So if I box this first indication, I can have it display using my dynamic views and my soft gates. I can have it display just this region in here. So I can see my lack of sidewall fusion, and my position of my probe is updated to that position. I can also see that, of course, in my TOF data lining up. To have a look at this next one, I'm going to move my cursors. Now I have my root indication there in this location. I'm going to skip over this one to my porosity. There's my porosity in the middle of that weld. And just to go back, oh, I've zoomed in on my indication. So on that view, so just to go back to this one, you can see this is my toe crack here. So I can really get an accurate measurement from that. And this has combined all of those TFM modes together and the data into one data set. And that's the end of my short live demonstration. One other thing I wanted to share is just about, I've talked about the TOPAZ today, an UltraVision platform, and now we're very happy to be partnered inside the Eddyfi Technologies group. And of course, now we have the best of the leading technology to offer you, from TOPAZ instruments and also the Gecko and Mantis from M2M business. So really, we have a whole scope of tools available, including scanners, to solve a whole host of applications. So we have a solution for every application and the right tools for these jobs. So thanks very much for your attention, and any questions, please bring them up. I think I might see some on the screen. Okay, can TOPAZ do compound scanning? Yes, is the answer to that. TOPAZ, onboard the instrument in UltraVision Touch, you can set compound scanning. It's very easy. You get an option in your calculator for azimuthal, linear, or compound. So it's very easy to set that up. Next question, what probes and scanners can be used with the TOPAZ? So really any conventional probes within the frequency spectrum that can be handled by the TOPAZ, which is standard for NDT applications. For phased array probes, of course, we have an IPEX or a ZPAC connector, so any ones can be directly connected to that. And then sometimes we need an adapter to take other connectors, but they are available. Scanners wise, we have a DE15 encoder input. So if you have that on your scanner, you can plug it straight in. It takes standard quadrature encoder inputs for manual scanners. And there are also adapters available for that as well. If there's a different one, you might have a LEMO 16 is quite common on scanners now. So there's a small adapter to adjust that, so you can plug them directly into the TOPAZ. How many focal laws can be generated at the same time? It varies by instrument. With the TOPAZ 16, it's less than the TOPAZ 64, but we're up to 1024, I think, on the TOPAZ 64 currently. Corrosion mapping, yes, I think I showed a couple of examples of corrosion mapping. We got some nice tools on board, and the TOPAZ 16 is a good tool for corrosion mapping. We have live, what do we call them, floating gates. So gates will float automatically at the minus 6 dB drop position of your signal. So you can set that over your back wall and maybe a second back wall, and it will automatically float, which means we get accurate amplitude information. It's going to read that from the peak, and for time of flight, it will measure at the crossing point. So no matter the amplitude of the signal, we get an accurate time of flight information. As I mentioned in one of my slides, there's some statistical tools in analysis for corrosion mapping. So you can have it automatically tell you where your minimum thickness is remaining in your component. And also you can set a threshold. So let's say you have a 10 millimeter thick component and you're interested in how much of it is below 8 millimeters. You set your threshold at 8, and then it will give you a reading of how many millimeters squared is below that, that threshold thickness. And that can be for the whole data or in a contour box. Is there a desktop version of UltraVision for analysis and reporting? Yes, there is. There's UltraVision Touch on the desktop. So there's a PC version of UltraVision Touch, which replicates exactly what you have on the instrument. So very user-friendly, but with some advanced tools. And there's UltraVision Classic, and there's several versions of that, depending on what you want to do, all the way up to working with CAD components to do a lot of analysis and reporting there. Any specific model recommended for weld inspection? They all do weld inspection. As a rule of thumb, we more or less say with the 16128, you can handle up to 50 millimeter thick carbon steel weld very well in phased array. The 32, maybe up to 125, 150 millimeter thick carbon steel, and the 64 aperture above that. There's some overlap, of course, and the 64 will do everything. For dual matrix array, so any austenitic welds, any stainless steel welds, then the 32 is the instrument, or the 64. And again, depending upon the thickness and complexity of that, we might choose dual matrix array probes with more or less elements, but either one can be used for that. Okay, looks like that's it. Thanks everyone for tuning in. Nice to be here. Any questions, feel free to email me or my colleagues, and we're happy to answer. Thank you.